Few discoveries have had as much impact on mankind as that of controlling fire. This skill has enabled man to march rapidly towards civilization. With the aid of fire, he learned to keep himself warm, cook his meals, make pottery, and extract metals. There is, however, another side to fire, namely a deadly, uncontrolled natural force, with the energy to raze an entire city to the ground. Today, of course, we have the technology to detect heat, smoke, and gases arising from a fire. In addition, we have regulations, which require buildings and means of transport to be designed and built with fire prevention and escape in mind. And of course, we have the fire services to call on in an emergency. One would think, therefore, that things are under control, that man has mastered all aspects of fire. Nothing could be further from the truth. Major fires occur daily in every region in the world. They continue to increase in frequency and severity and pose a significant problem to modern society. In many cases, this is as a result of products that contain flammable synthetic materials. This video shows how fire safety standards can reduce the flammability of products and hence extend the time available to intervene or to escape safely. The great majority of fires occur in our living environment, which is no surprise, given the number of things that can go wrong and aggravate the situation. For example, electrical and electronic equipment, used everywhere in modern society, can be both a source of ignition and a contributor to the fire load, which is the total quantity of energy which could be released by combustible material in a room or office. A medium-sized TV set, for example, contains a mass of plastic equivalent to around 5 litres of petrol. And of course, we have upholstered furniture, which is often a much greater fire load, and furnishings such as curtains which can help spread flames rapidly to adjacent areas. Clearly, we need to identify and to assess the risk from the critical areas of buildings and their contents. And the same principles hold good for transport, such as cars and buses. Many materials used in transportation vehicles are combustible, often dramatically so. In addition to the fuel, interior products in mass transport and cars are of concern. High fire safety standards exist for ships, aircraft and railways in most parts of the world. However, they are comparatively lower for cars and buses, as seen by the frequent reports of fires in these types of vehicles throughout the world. Particularly serious bus fire incidents have occurred globally in the last decade. The reason, unfortunately, is that international flammability standards for cars and buses date back to the 70s, before the large-scale use of plastics. A few car manufacturers, however, do apply higher standards of their own accord. Standards, then, play a critical role in fire safety. Let's find out more about them. A fire safety standard will require standardized methods to demonstrate compliance. These test methods determine how a product or material or component will react to a fire under specified conditions. The objective of a fire test method are to measure one or more of the key parameters. This includes ignitability, which measures the extent to which a material can be ignited, flame spread rate, the distance travelled by a flame front per unit time, heat release rate, the thermal energy released per unit time by a material during combustion, smoke production, the characteristics of smoke emitted such as density and volume, and toxic gas generation, the characteristics of the substances emitted such as carbon monoxide and acid gases. There are actually several hundred fire test methods developed by different standards bodies for all manner of products and applications. Let's take a quick look at a few common ones. This is the single burning item test, already seen for the classification of building products. Here is the popular UL94 test method for flammability of plastic materials used in appliances. This is the small flame test, also used to evaluate ignitability of building products. This is the cone calorimeter test, another widely used method to predict fire and smoke behaviour. In this example, we can see a clear difference between a material which meets a standard and one which does not. Fire safety standards are often developed in response to a major fire or a serious trend of incidents. This involves bringing together a range of stakeholders, such as manufacturers, consumer organisations, test houses and government representatives. The process therefore takes time, sometimes 10 years or more, to arrive at a standard that everybody is happy with. But when a standard sets high performance requirements, it can make a huge difference.